Greetings. This is a sample confidence interval problem for the X-bar mu world using the t-distribution. You can see the problem 10.31 out of your book. I don't remember what page it is, but it's very close to where your homework is. And your homework is on page 649. So I believe that this is on page 649 or 650. And we are looking at give it some gas. This is a kind of almost exactly what happened to the Honda Civic lawsuit. And then I believe it was the Hyundai Sonata that was also, they were accused of not advertising the correct mile per gallon for their Sonata. So basically what happens here is we have a sample of 20 mile per gallon results after filling up the car, and we are going to do a confidence interval to find out where we think the true gas mileage is for this car. You, therefore, can do this along with me in your calculator by turning to this page and entering all those data points that we see up here, the 20 data points, into the list called MPG. And that's how you can do your AMBER and your CSB homework as well. Just enter the data yourself. Okay, step one of panic is to identify our population parameter. We are trying to capture the true mean miles per gallon for this vehicle. And it doesn't tell us the make or model, but we are trying to find the mean mile per gallon for this vehicle based on these data. So I kind of just copied out of the book. The A, the assumptions or conditions, this is the time consuming part. The first part, it says somewhere up here that we are going to consider these as a random sample. It says right here, a random sample of 20 of these records. So we're going to say that X bar is from a simple random sample as stated. X bar again referring to our one sample of 20. So master X bar, sample distributions balance point, is an unbiased estimator of the true population mu, which we defined in the P part. The next part is where we have big changes compared to what we did in the PP hat world. We have an n equals 20. So we have to examine what the data, what the sample looks like. And if it looks like it's not much skew and definitely no outliers, then we can continue. So to do that, we bring up our calculator, stat plot, turn it on. First thing I'm going to do is graph the histogram, zoom 9 it, and we get that. Doesn't look very bell-shaped. Doesn't look very skewed either. And the beautiful part here that you will love is that you don't have to label, title, or anything. Just sketch a quick picture of it. Now, the other thing I would do, and you can really do one or the other, but I would look at both, is I would do a modified box plot because this calculates the outliers, and then you can say with confidence that you know for a fact that the skew is, not too severe here because the boxes are relatively the same. The width and the whiskers are somewhat similar. We definitely have no outliers. So now that we have those two pictures, and again, you only have to write down one, we would say the sample shows no outliers and small to no skew. So the sampling distribution is approximately normally distributed. And then finally, 10 times 20 is 200. And we are going to say that 200 is less than the total fuel tank fill-ups. In other words, it's less than the population. So the sampling distribution standard deviation is S sub x divided by the square root of n. Okay. All right. N is a change also. Name the test. We are doing a t interval for a population mean, and it's very important that we say population here because we're trying to capture the population. We don't have to capture the sample. We already did it. Okay. With 20 minus 1 or 19 degrees of freedom. Okay. I believe if we look back up above, it asks us to do a 95% confidence interval. So when I go to calculate the interval, I am using x bar plus or minus t star s divided by the square root of n, and my C level is 95%, and sadly in the Z world I know what that would equal for a Z star upper critical, but in the T world I'm going to have to calculate it. So this gives me 0.025 in both tails. I'm looking for the upper critical T star. So I'm going to go to my program, and this is the one that you don't have if you weren't in class, but I'll show you how to get around this in a minute. The tail area is 0.025. The degrees of freedom are 19. Again, the mean is 0 and the standard deviation is 1. Gives me an upper critical T of 2.093, which I will just round to 2 decimal places, and I will use 2.09. Okay, so I know that T is 2.09. I know that N is 20. I don't know my S and I don't know my X bar, but I have a calculator that can calculate that for me. Calculate one variable statistics on my list MPG, and it gives me 18.48. Need this screenshot as well. It gives me 18.48 exactly, and I'm going to round my standard deviation to 2 places, 3.12. So I need that standard deviation of the sample, and I need the estimate, which is X bar of 18.48. And now, because I'm Mrs. Garrett, I like you to do this in pieces parts for things that are coming in the future. So the first step is to do 3.12 divided by the square root of 20, and I get approximately 0.6976 yada yada. I'm going to leave that in my calculator. Now I'm going to take that times 2.09, and I get 1.458 ... And now I'm going to do 18.48 plus my second answer, which gives me 19.938. And if I subtract my 1.458095 from there and subtract it again, I can get the other side. And I have about 17.02. All right, that's my confidence interval. And now I'm going to show you, if you don't have the program T area, how we can double check that. We can double check this and get around having to calculate the t-star just for checking purposes and for those of you who weren't in class today by choosing stat over to tests down to a t interval, which is number 8. We have data. It is called MPG. So go grab that. And I want to do a 0.95 level. And I want to calculate. So there we have it. It gave me everything that I needed. And it verified that I, in fact, did my math correctly. You can see this number here and that number there. You can also see how it calculated the mean and the standard deviation for us. So my last step then is to write my conclusion. I am 95% confident. And we discussed what that phrase means. It means something special. That the true mean MPG for this vehicle is captured by the interval 17.02 to 19.94 miles per gallon. So if in fact they had advertised that the Honda Civic could get 20 miles per gallon city, this particular vehicle did not. And if they tested many Honda Civics over and over again and kept coming up with confidence intervals that did not contain 20, for instance, then that would be how they lost their lawsuit. Again, you can use this stat test t interval to do your 2 homework problems tonight. And tomorrow I'll give you the t area so you can do it by hand and then use the stat test to check your work. Have a great evening. Talk to you later.